mentioned. If you have any questions, do feel free to use the Q&A function in order to get them in, and then we'll get them answered throughout the session. Week 1 lecture, and we had a few practice problems involving control flow as well. So this involves mastering for loops, while loops, and if-else conditionals. We'll be able to trace and analyze the flow of Python programs that use conditional statements and loops. We'll be able to apply for loops and while loops to repeat actions based on specific conditions, and we'll be able to write and modify conditional statements to control the execution of code based on logical expressions. So a little bit of an overview of why control flow is important to begin with. So you might have seen this picture from lecture. And basically, this is the river of control flow. The big idea is that you're trying to control your code and do specific parts of your code depending on conditions and logic. We start with for loops, then there's while loops, then if and if else, and eventually you'll make your way up towards the control flow mountain, as you can see right here. Here's a little definition of control flow that I made. Yeah, it's basically just a way that the program decides the sequence of executing instructions, moving from one step to the next based on conditions and logical rules. And mastering control flow is very important because it helps with building programs that handle complex decisions and behaviors. For example, if I'm making a game and I want people to only move if they're pressing the arrow keys or things like that, then I can use control flow and use a bunch of if-else statements to figure out what input key they're using and then make them move based on that. And that's just an example in game development. Next, we'll jump into for loops. So for loops are used to repeat code blocks a specific number of times. So when you're writing a for loop, this is the typical syntax. You'll have a for keyword, then you'll have I, which is a variable, and you can name this anything, but the typical convention is to use the letter I. Afterwards, you'll have the word in, and then the function range, which accepts a number, however many times you want to do that chunk of code. So in this case, 10 times. And then you'll end with some colons. Afterwards, you'll indent the rest of the code. And this indicates that you want to do this block of code 10 times, or however many times you said right here. In this case, I'm putting the beeper down 10 times. Afterwards, when I'm done with writing the for loop, I'll remove the indentation and continue writing my code as normal. So after I put beeper 10 times, I want to get out of the for loop and move once forward. So as you can see here, this is what the output of the code would look like. I put 10 beepers down. Afterwards, I'm no longer in the for loop and I move forward once. So this kind of like any questions, feel free to pop them in the Q&A and we'll answer them afterwards. But yeah. Oh, I lagged out for a bit. Yeah, I'm so sorry about that. I think my Wi-Fi is a little like bad right now, but hopefully the big point. Repeat the last 30 seconds. Yeah. So I have this move right here. It was inspired by 10 beepers. 10 beepers does not have this move. And the reason why I added this move here was to kind of indicate that if you want to keep writing code after the for loop, you would remove the indent and then write your code as normal. Okay. So next I'll go over reviewing the square problem. So in Mehron's lecture about for loops, he talks about the square problem. And this is also available on this link right here. But the square problem basically starts with Carol in the very corner. And Carol is basically going to make a square. So it's going to look something like this, placing beepers right here, then here, then here, and then here. And eventually Carol has a square. So the first thing you might think of is, hey, I'll place a beeper down, right? And then I'll move over one step, and then I'll turn. But how come I'm not just placing a beeper before turning? For example, I could just move and then place a beeper while returning first. And the reason for this is because if we want to use for loops for this problem, we need our pre and post conditions of the loops to be the same. In the lecture, Mehron mentions that post-condition and precondition needs to match. What this means is that the precondition in this case is Carol is not on a beeper, and the next space Carol is facing is the space Carol wants to move into. And the post condition in this case also matches. For example, the post condition would also be that Carol is not on a beeper, and the next space Carol is facing is the space Carol wants to move into. To visualize this, this is what it kind of looks like. So in the very beginning, before the for loop, the precondition, Carol is not on a beeper. The next space that Carol wants to move to, Carol is facing towards. So Carol wants to move into this space next, and that's where Carol is facing towards. Then you do the set of instructions. So we do the put beeper, we do the move, and then we do the turn left. And you get something like this. And this is after the for loop. As you can see, the post condition is the same. So Carol, again, is not on a beeper. And the space that Carol wants to move towards is the space that Carol is facing towards. So in this case, Carol wants to move to this space next, therefore Carol is facing it. So if you do the same set of code again, you put a beeper down, you move one, and then you turn left, you can see that the post condition again is the same. Carol is not on a beeper, and the space that Carol is facing is the space Carol wants to move into next. So as you do the code again, put beeper, move, and turn left, post conditions, same thing. And lastly, if you do the code one more time, so 4 times now, you put the beeper down, you move, and you turn left, you can see that Carol is now in her original position, and a square has been made. So we did it. If you translate this into code and into a for loop, you'll see something like this. For I in range 4, colon, put beeper, move, turn left. And you can note that this code right here is the same code that we've been repeating over and over. And the pre and post conditions are the same each time we iterate through this for loop. All right, so I'm going to stop here and I'm going to answer any questions about for loops, and Cameron will be helping as well. But let me open up the Q&A if possible. Okay, so for Q&A, we have 8 questions now. I think Cameron kind of went through and answered majority of them already. But okay, I think most of the questions are answered already, but I'll read them out loud so that way everyone gets a chance to hear the questions as well. So will the recording of the meeting be shared with us? Yes, after it's done. And I also have another session of this at night, for me at least. So in like 11 hours from now. Someone mentioned that, okay, that was like section related. I'll skip that. Okay, I don't think any of the questions are relevant to like for loops specifically, but if you guys had any questions relating to for loops, feel free to pop it in the Q&A. Someone mentioned, please repeat the post condition. Yeah, so right here, the precondition is the same as the post condition. So number 1, it's Carol is not on a beeper, and number 2, it's that the space that Carol is facing is the space Carol wants to move into. So as you can see, the post condition is the same. So after doing the for loop, which is the post condition now, you can see that Carol is also in a space that's not on a beeper, and the space that Carol is facing is the space that Carol wants to move into next. So Carol's facing this way, and Carol wants to move into the space next. So those are the pre and post conditions, and they match up. What do you do with different size worlds? 3x4 and 5x5. So in this case, 3x4 and 5x5 should still work the same, since you're just going into a square in this little corner right here. Cameron mentions that a good question is, if loops aren't nested, can you reuse variables? If loops aren't nested, yes, I believe you can reuse variables if the loops aren't nested. Because after Python is done with that like for loop, you can use the same variable again. It's not good practice to use the same variable nested within a loop because it's reliant on those two variables as they're going through the loop. But once you're done with the for loop, then you can use the variable again. But if it helps you with like just like naming convention, you could kind of totally do something different. Does pre and post condition needs to be the same in for loops, or does it depend? So typically best practice is for pre and post conditions to be the same um before and after doing a loop. That way it can repeat the code again without any like errors. And it's kind of a good check to make sure that like your for loop is written well. But yeah, it doesn't necessarily always need to be the same, but in most cases it is the same. Okay. So if you have any more questions about for loops, feel free to pop them in the chat or the Q&A. I think Cameron's going through and answering questions in the Q&A right now. Does the order of the functions in the body matter within an if I range? I completed this exercise, it worked, but the order of my functions are different than your demo and what's in the sample. So I think what you're asking is like if you could like rearrange these steps. And I think if it worked out, then that's totally fine. There's no one right way to write code. Just make sure that your pre and post conditions are the same though, as a good like sanity check. Okay. All right, I will move forward towards while loops now. Okay, so the next thing is while loops. While loops are used for indefinite things. So for example, it'll keep repeating the code block until the condition is true or met. Unlike for loops, which kind of rely on like you telling it how many times it needs to run. So writing a while loop looks a little different. You'll have the keyword while, and then you'll have our condition right here, and then colons. Afterwards, you'll indent your code again, and whatever's indented after the while loop is basically repeated over and over. Afterwards, if you're done writing the while loop, then you can remove the indent and continue writing your code as normal. So in this case, front is clear is our condition, and it can evaluate to either true or false. If it's true, then we'll tell our code to keep doing this over and over until eventually it's false. And once it's false, we'll stop doing it. So in this case, we're checking is front clear? If so, I'll move over. Is front clear? Yeah, I'll move over. And then I'll hit a wall and eventually it won't be true anymore. So I'll stop moving and then I'll exit out of the while loop and then I'll place a beeper. And that's what's happening in this final picture. And this is inspired by move to wall. Okay. So you might have seen this picture right here in lecture, and basically it says that a program executes one line at a time. And the while loop checks its condition only at the start of the code block and before repeating. What this looks like is basically this. So it'll ask this condition or it'll check the condition at the very start of the while loop. And as you can see, it's true. So then we move. Then it'll ask the condition again since we're restarting the while loop. So then it'll ask it again, is front clear? Yes, true. So we'll move over one more time. And then eventually it'll ask, is front clear again? But this time it'll evaluate to false because there's a wall right here. Then it'll tell us, hey, we're done with this while loop and we can move on with the rest of our code. With a lot of while loop problems and using while loop, you'll often run into a fence post problem or an off by one problem. For example, in this problem, you're trying to fill all the beepers in this row right here. But as you can see, that there's a leftover one without a beeper. So this last space right here doesn't have a beeper. To fix this, all you need to do is put a beeper at the very end to account for that one off by one problem right here. But just keep in mind when you're writing while loops for these off by one errors. For writing conditions, you're also able to use some Python keywords to check multiple conditions. For example, you can use and or. For example, this is how you would typically write it. You'll have one condition and another condition, and then you can kind of like put them together with and or. So I wrote while front is clear and beeper is present. And this will only happen, so the move will only happen if both of these things are true. So if front is clear and beepers are present, then I'll move. Again, these are the conditions in Karel. So we have positive conditions and negative conditions that you can check. And then okay, so I'm gonna pause here and answer some questions, and I know like Cameron also popped a few really good questions in the chat as well. So yeah. So Cameron said, "Can you put a if condition inside a for loop?" Yeah, of course, totally. You can definitely put if conditions inside of the for loop. You can also put them in the while loop and execute certain parts of code on top of your already like while or for loop like things. So like I'll show an example of that later as we're solving a problem together, but definitely you could put if conditions inside a for loop. Breaking down front is clear's interaction with beepers could be helpful. Okay, so beepers could be helpful. So like this statement right here, definitely. So basically I wrote this code with like the thought that I would only move forward if both these conditions are true. So if front is clear and beepers are present, move. What this means is that if Carol is standing on a beeper and Carol is able to move forward, then Carol will move forward. And this will keep happening until there are no more beepers or if front is no longer clear. I think that's what Cameron was trying to get at for that question. But if you have any more questions about while loops, feel free to post them in the Q&A and also in the chat, and I'll look through the Q&A right now. So someone mentioned where can you put comments? I'm not sure if that's referring to Python comments or like just comments in the chat or Q&A, but if it's Q&A or like chat, feel free to just put it in either or. But for Python comments, you can put comments kind of anywhere. So like this is an inline comment. I just put it on top to make sure that it's more readable during the slideshow. But you can also put it like next to the code that it's executing, or if you have um like longer like paragraph comments, I guess, describing what a function is doing, that can go right after the definition. Someone mentions, can we use for loops in while loops? Yes, you can, but that gets a little tricky. And I'm not sure if you necessarily need to do that most of the time. Kind of like a case by case thing. You could do it, but you might get a lot of loops and then it could get confusing. People typically do like nested for loops rather than like a for loop in a while loop. Um, okay. And then Cameron mentions in some decomposition problems like hospital care, you might. Okay. So a nested loop is when you have like a for loop and then a for loop within that for loop. I'm gonna read some more Q&A questions real quick. Can I use else condition? Oh, if else conditioning in while functioning? Yes, you can also use if else in within whiles as well. Always having fence post issues. Yes, make sure to always double check your code and ensure that there's no fence post issues. Um, So we'll go over, someone asked like, how can we create variables in for loops in place of I for I in range 10? So you can just change the name I to anything, honestly, but most people use I in this case, but it could work with like J or K or whatever. We'll talk more about variables in, I think, week 2 and 3, so we'll get some more practice with variables then. Will making a nested function make programs slow? A lot of binaries in it. In terms of reversing the binaries, what will be the good solution? So in terms of like nested functions making a program slow, typically for like if you're ever doing a nested for loop in Carol, it won't be like as slow since you're defining like however many times you want to do it, but it for like different things that could change in size, definitely having nested functions could make things slow over time. And I think we might talk about that more in the future as you're learning more about for loops and their use cases. How can we create variables in for loops in place of I for I in range 10? Oh, I think I answered that just now already, but okay. I think the rest of the questions were already answered. But all right, we'll move to if else next. And then we're at 11:21, so hopefully there's enough time to go over a problem together. So for if else, it's very similar to writing conditions, which you mentioned in the previous slide. So in this case, you'll write if, and then you'll have your condition, the colons, and then you'll indent your code, and whatever's indented is gonna be executed basically. So if the condition is true, do this part of the code. Otherwise, do this part of the code. So let's do some practice with this. So what code is executed? So if front is clear, move. As you can see here, Carol is facing against a wall, so front is not clear. So this is actually false. What will happen is we'll actually put a beeper instead. So put beeper. So if front is clear and beeper's present, move. As you can see here, front is clear, but there are no beepers present, so you won't move actually. So nothing happens. How about this one? If front is clear or beepers present, move. Else put beeper. So you can see here that first we'll check our first condition. Is front clear? Yes, front is clear. Are beepers present? No beepers are present, but since it's an or, either or can be true and it will evaluate this code. So since front is clear, we can move. So we have a true and a false, but since it's an or, it evaluates this entire condition evaluates the true. Okay, and then that was all I had for if else. Hopefully that helped with like the syntax of if else and practicing a bit about if else as well. We'll move on to Zigzag Carol next, but I want to stop here and answer any questions about if else. And feel free to like post in the Q&A or also in the comments. Do you use if else with fence post row? So by fence post row, I think you mean like this problem right here that was in lecture. You probably wouldn't need to use an if else to solve this, since the fence post issue is, oh, I'm missing a beeper at this very end spot. The solution for that would be to add a beeper at the very, very end. So once this while loop is done, you can put a beeper at the end. So you don't necessarily need an if else here, but you could definitely use if else for other problems. Are there any limits to the amount of conditions? Technically, no, but for readability, I don't think you should do more than like maybe 2 or 3 conditions. But technically there are none. You can do a bunch, but then the logic gets a little confusing over time. I don't understand how turn left works. Can you explain? Yes. So turn left means that Carol is just going to turn this way. I think turn right does this way. But for turn right, you need to do 3 turn lefts. So turn left is like this way. Hopefully you can see my mouse cursor. And then turn right is this way. Right? Or is it the other way? Sorry, I think it's the other way. Turn left is this way, and then turn right is this way. Do we always need to write down hashtag explanation? Yes, that's a great question. I think, okay, so I don't know what this means. Cameron would like to answer this question live. Okay. Oh, like indicating that I'll answer it. Yeah. So, these comments are just kind of for me to like annotate the notes, but you definitely don't need to always write these comments. Only write comments as you find necessary. So if you're doing something really confusing and maybe like someone reading your code won't necessarily understand it right away, writing comments might help with them as they're reading through your code. And it also really helps to document what each function does. So in some previous examples, you might have seen like a bunch of three quotations and like a big block paragraph. That's really great for like explaining what a function does. And then these inline comments, which are done with hashtags, are great for explaining line by line comments. While condition 1 or condition 2 or condition 2 and if a condition, what is the difference between them? Yeah, so the keyword and if, or sorry, and or. So and basically means that both of these conditions need to be true, and or means that just one needs to be true. So either this condition or this condition can be true. How many times can and? Oh, a lot of the questions are getting out of order. Is this a second makeup session? No. I missed my first section. We'll have access to the session recordings as well. We'll follow up with that one by one key basis, but I'll move on to the next question. Okay. Is there any type of loop where you have to do a while loop while running within a while loop? I would say probably you could technically run a while loop within a while loop, but I don't think that it's very common to do that. But you could definitely do it. What's the difference between while loop and if else? So while loop runs indefinitely and if else only runs once, so it'll only execute once. Basically while is to do it over and over and over again until the condition is met, or until the condition is false, becomes false. And if else basically only does it once. So if you're going through code and you run through a while loop, you're gonna do that while loop over and over until the condition is false. But if you run into an if else, then it's only gonna evaluate once and then do that block of code once. Yeah, once. That's the difference. And if you want to like repeat the if else like conditionals, then you can definitely put them within a while loop to evaluate those if else's a bunch of times. Okay. I think I answered most of the questions that needed to be answered live. But if you have any more questions, feel free to pop them in the chat. And I know Cameron's also answering some questions that might be more about like logistics and things like that too. Someone mentioned, is it necessary that we provide the else part? So you don't necessarily need an else if you don't want an else. So for example, I have some code here where I only have an if. So you can do just an if, but if you need like an else, like you want to tell the code to do this otherwise, then you can use an else. Okay, I think I answered all the questions. So we'll move on to the next part of the review session, and then we'll do some more questions at the very end. So the very next problem is zigzag Carol, and this kind of problem involves using a lot of the things we've kind of learned and synthesizing those ideas together. So you start off a world where you start with Carol right here, and you're trying to make a zigzag pattern like this. And then you want Carol to end at the very bottom right-hand corner. This is the link to the IDE if you guys want to click on it. But just on first thought, we need a function where we can place a beeper here, then move up and place a beeper here, and do the same thing over and over. And you can see here that I'm repeating this kind of motion 3 times, right? I'm placing a beeper, I'm going up, I'm placing another beeper, I'm here again, I'm placing a beeper, going up, placing a beeper, so on, so on. And I'm doing this zigzag pattern over and over. So by intuition, we might think, hey, I might need some sort of while or for loop here maybe to do this over and over. Then I also might need a function where I go back to this ideal position right here. So you can see here that I can do these positions right here, or these motions right here, if I'm standing on these beepers right here. So I might need a function where maybe I return to this ideal position. So that might be a really good helper function. And just to draw it out, maybe it might look something like this. I start here, I move up, or I place a beeper, I move up, then I move over, I place a beeper, and then I go down and I move over, and I'm at this like ideal position again, and then I can repeat these steps over and over until I eventually hit a wall. So this is kind of like the layout for how we might tackle zigzag Carol, and I want to go into like the IDE and kind of pseudocode this out with you guys. Okay. Oops. Okay, we'll hide the solution. Okay. So the first idea is, again, we might have like two functions to help us out, as I mentioned. We might have a function that does this like little zigzag right here, and we might have a function where we return to an ideal spot to do these zigzags. So we might have to do some sort of like motion like this, basically. The first thing is I'm just gonna type that out. So maybe we'll start off with step 1. Carol is in this very corner right here. We want to go up. Then in step 2, we want to move over this one. So we need to go up and then we need to move over. Move over. Oh, but the very first step, I totally forgot this. We'll call it step 0. Place a beeper. So place a beeper, go up, move over, place a beeper. Right, so we'll have a beeper here and we'll have a beeper here. And then we want to return to this spot right here so we can place another beeper and then go up and place another beeper. So how can we do that? Could you possibly zoom in? Definitely. Okay. Hopefully that's better. Okay. Then if we're tracing through our like pseudocode, we'll have a beeper here, we'll go up, we'll move over, we'll have a beeper here, and then we'll want to go down, so go down, and then maybe move over again. So then we're at this like ideal spot to repeat this step right here. So maybe step 6 could be. Okay. So if we walk through all of our steps so far, we have placing a beeper, going up, moving over, placing a beeper, going down, moving over, and we're not at this spot right here, and then we can kind of repeat 0 to 3 again. So we'll go up again, place a beeper, then go up, then move over, place a beeper, and then do this part again. So you can see here that maybe the next step might be to repeat steps 4 to 6. Okay. Oh. Okay. So then maybe the next steps are to repeat 4 and 5. So place a beeper, go up, move over, place a beeper, go down, move over, and then repeat steps 0 to 3. So place a beeper, go up. Maybe it's a little bit easier if I annotate this actually with the zoom feature. Do that. Okay. So I'll have a beeper here, move up. I'll have a beeper there. I'll move over. I'll have a beeper there. The X's are beepers. And then we'll go down. And then we'll move over. Place a beeper here. Go up. Move over and place a beeper here. And so on, so on. And as you can see, if we repeat these steps over and over and over again, we'll eventually have the beepers over here, over here, over here, over here, over here, and over here, and eventually go down and hit a wall. So it kind of, this like little loop right here where we're repeating steps 0 to 3 and 4 to 5 over and over until we hit a wall, kind of like tells us we might need like a for loop or a while loop somewhere to accomplish this task since we're doing something over and over again. Okay, and then I will remove the annotations. And let's just start coding this out, basically. So let's kind of decompose into another function, and I'll call it like, we'll call like this motion right here a zigzag. So one zigzag motion. So one zigzag motion like this. We'll start by placing a beeper. and then we'll go up. So to go up, we need to kind of face this direction. So we need to be facing north. So what should we do? I'm thinking we should maybe turn Carol and towards the left direction, maybe. If I just try my code, I can see if, oh, sorry, it's a beeper. Okay, so you can see here that so far my code, all it does is it puts the beeper down and then it turns left. So that's all that we've done so far. But we've put down the first beeper, which is great progress. Okay. Yeah. And let's do the next thing. So we want Carol to move over one right here. So let's do a move and let's test our code out. So now Carol is up here. And then we want to place, we want to move over here and then place another beeper. So let's turn Carol facing this way, and then place a beeper right here. But you might be asking, like, how can we do that? Maybe we need like to turn right. And in that case, we've seen like this kind of decomposition of turning right already, where we have right here, turn right, a bunch of turn lefts basically. So we do something like this, copy and paste the code in the documentation and use that function. So let's do a turn right. Let's try it again. So Carol is, we were right here and then we moved up and then now we're asking Carol to basically turn right. So it does all of this. And then we need Carol to move over. So Carol's gonna move over one and then put another beep down. So let's try that out. Let's see what happens. Okay, so you can see here that Carol turns right, then Carol moves over, and then Carol puts down a beeper, and we get the zigzag pattern that we wanted. So if you were to isolate like just this first half, we've accomplished basically this one motion. And that's what one zigzag should be doing, this one motion over and over. So looks good to me. And we're going to need to make some edits this later on, but just for now, let's do this. I think technically, actually, we'll fix the function right now, actually. So what happens if you're facing like just a 1x1 column, or you're in a 1x1 column, so Carol's like right over here or something, and moving like forward hits a wall. We don't really want like that to happen. So we want to be safe and ensure that there's no wall in front of us when we're doing this forward move right here. So just to show you guys. Okay. So when Carol like moves forward right here, what happens if Carol collides with a wall? We'll run into like a really big error and our code will be bad. So what we need to do is we need to ensure that Carol doesn't hit a wall. So what we can do is we can actually write an if statement right here. So if front is clear, then Carol is able to do the next step right here. And only if front is clear. Because if there's a wall right here and Carol bumps into it, then we don't need Carol to do any of this code right here. Then that's why you use an if statement. Okay, and another thing is if you wanted to make your turn right look a bit nicer, you can maybe do like a for loop, but I mean, this is totally fine as well. It's kind of the same thing. The next step is we need Carol to go back to the quote unquote ideal position to do this again. And the ideal position for the next like chunk would be right over here, in this spot. So how do we get Carol down to this spot? We probably need to decompose into another function that can help us with this. So let's try this. We'll call it return ideal. You can call your function anything that like is relevant and sounds good, and describes what you're doing. So like for example, one zigzag motion describes this motion, and I'm calling this one return ideal because I want Carol to return to this like ideal position to do another zigzag motion. I'll call it ideal position. Okay. So the next thing is we mentioned we want Carol to move down and then move over and then return to this ideal position right here, or go to the next ideal position. So I want to make Carol face downward so Carol can move down. To do so, I think that would be a right turn. Let me just try that. I'm like kind of directionally challenged, so honestly, it's totally okay to test out your code multiple times and make sure that, you know, you're doing what you need to do. So I didn't call this function yet, so it didn't do it, but let's call this function right here and just check. Okay. So I called the function in the main function, so it'll be doing this. Let me just check. So after it finished one zigzag motion, it does this. And you can see here that it turns this way, which is facing down, which is what we need. So it looks good. And then let's just move over one and see what happens. Okay, so now Carol is moved over here, and I want Carol over here. So I'm gonna turn Carol over again. Instead of a right or a left, let me think. I think that's a left, guys. So turn left. Let's try it out. Okay, so Carol is now facing this way, and then let's just move Carol over. Okay, so Carol was here and then, you know, turned left and then moved forward one. So now Carol is over here at the very end of return ideal position. Carol is right here. So you might see that like, hey, this is a bunch of, I need to kind of repeat the same code again. And I don't want to copy and paste this over and over, right? Like I wouldn't want to like copy and paste this over and over. It's kind of ugly. And also what happens if you run into a wall at the very end? There's something to check for that. So let's figure out a way to kind of rewrite this so that Carol is able to redo the same motions over and over without running into a wall. So you might be thinking, maybe we could do like a while loop here while front is clear. That way, if Carol does face a wall or run into a wall, it stops doing all of these motions. So, oh, okay. So with this while loop, I can see that I got the entire like zigzag pattern going, but I run into a very error at the end. And the error is what happens right here in the red. So it says when I move forward, there's a wall, and there's something checking that like there is a wall. So Carol's like, whoa, what's happening? And I get an error. So I probably want to write an if statement right here, just to double check if I can make that move, because otherwise I'm gonna run into that error at the very end. Let's try it now. Okay, awesome. So at the very end, we ran into a wall, and we just want to double check that it's safe to move before moving to avoid any errors. So that's why I made this if statement right here. So yeah, this is kind of a walkthrough for zigzag, and hopefully that was helpful. But the big idea is we were able to use if to check conditions, like if front is clear, and we were able to use a while loop to check if front is clear as well, to ensure that we're not running into any walls while we're doing our motions. But yeah, if you guys want to read over maybe more documentation about this solution, then we have the solution available right here. And you're able to read all the comments and notes about each function. And they name their like functions a little differently, but it kind of does like the same big idea. Okay. Did anyone have any questions about zigzag? And hopefully the explanation and the walkthrough was clear enough. Could you explain why while loop is needed? Yeah, definitely. So when we have this while loop right here, it's because we want to repeat this over and over. Without the while loop, you get something like this. And again, make sure your indentation is right. But you get something like this. And I basically want to repeat this a bunch of times, right? So if I were to just copy and paste this like this, Carol could technically do all of this, right? Besides the fact that like I hit a wall at the very end, but I do like the motion over and over. And this is a lot of like repetition. And you can see that it's the same repetition over and over. And in that case, maybe I want to use a loop of some sort. So I can use while, and I have a condition. So the reason why I put while front is clear is because at the very end, you can see that Carol runs into a wall and there's an error, right? So it stops running. We need to make sure that we can actually do these motions over and over without hitting a wall. So our condition becomes while front is clear. And if you copy and paste the code there and you do it again, you can see that the condition prevents Carol from doing this over and over, because once Carol hits the very end of the world, this becomes false and we don't keep doing this. So we're done with doing all this code once we're at the very end of the world. Okay, someone mentioned I feel like while and if are same, could you differentiate them further? Yeah, definitely. So if you're running through code, you're doing line by line. So once Python hits a while, it tells Python, hey, we're gonna go in a loop, basically. And we're gonna keep doing these same things over and over again until this condition is true. However, an if only runs once. So when the code hits an if, it's like, oh, okay, I'll do this once depending on the condition. So if the condition is true, then I'll do it. If it's not, maybe I'll do the else, if there is an else. But it only does it once. Meanwhile, the while will keep going in a loop over and over and over again and continue doing this code over and over again until the condition is false. So while is like doing something over and over again, and if is kind of like doing it once if the condition is true. Okay. Jorge asked, I would just reduce the decomposition to 2 steps. Detect the repetition for the recurse block, correct for fence post issues. Am I being too oversimplistic, or is N versus MP problem? I'm not quite sure what you mean by N versus MP, but reduce the decomposition to 2 steps. So like do this and this into one, like combine these two. I think for the sake of like clarity, right? Like one thing is like going up this way, and then one thing is going back to the original position. We have 2 helper functions that we're using. And the reason why we want to do this is just for clarity and like to make sure that the code is readable. Yeah, kind of like the big idea, but I think you could totally like kind of reduce it down to like one helper function instead. Someone said, so helpful. I had the same problem when I went through the assignments, and now I know why there's an error in the end. Thank you. Yep, definitely. We just need to make sure that every move that we do is a safe move, and we don't want to like run into any walls. So make sure to always double check for that. I think like the big things to think about are fence post issues and also running into walls. And what was a typo error in move under if loop? Yeah, right here. So I think the error here was at the very, very end. If you didn't have this, Carol would kind of run into the wall. So I'll kind of remove it and show you. So you can see here that if we trace through the code, at the very, very end, Carol does one zigzag motion, and then we're like, hey, let's go to this function right here, return ideal position. So we'll turn right, then we'll move forward 1, and then we'll move after turning left. So we're facing this way, and then we move, but you can see here that we hit a wall. And that's why we need like that if statement right there. Because at the very end, Carol is going to be doing this function right here. And if we don't check if there's a wall or something, then Carol's gonna just move forward and hit a wall and we'll have an error. So make sure to always check if you can even move to begin with. Someone said thanks and someone said got it. All right, awesome. I'm glad that was helpful. And I think there's some more questions in the Q&A, so I'll also answer those. But we'll move on to the Q&A session. Okay. So someone said, can we create our own conditions, for loops and if statements? Yes. So you can write the condition to be anything, as long as it evaluates to true or false with conditions. So for example, Carol comes with a bunch of pre-made like functions to check. And all these functions right here return a true or a false. So these conditions will return true or false. And if you're writing like code in the future, you can definitely write your own functions to determine if something is in a true or false condition as well. Yeah, great question. Someone said, is it necessary that we provide the else part? I think I already answered this, but not necessarily. If you want to just use the if, then you don't necessarily need the else. If you're checking for one thing before doing it, then you can just use an if. For example, like when we did if front is clear. Can you try that on a different world? Definitely. So I think we have zigzag 2. And it's just like a shorter version of the world. But I don't know if there's any other worlds besides 1 and 2, but you're still doing like the same motions over and over, but you're doing it like you're not sure how many times you need to do it. That's why we're not using a for loop, we're using a while loop, since it could be, you know, we're doing the zigzag pattern twice, or maybe we're doing it 3 times. We don't quite know. That's why we're doing a while loop. Someone mentioned, I'm getting an error when using range in a for loop. Could you explain the correct syntax for using range in a loop? Yeah, great question. So let me go back to these slides right here. So right here. So the syntax is for, and then you have some sort of variable. Typically we use I, and then in range, then parentheses. What the syntax error, what error you're kind of running into in terms of syntax, but feel free to kind of elaborate more on that. But this is a typical convention. Make sure you're indenting correct. So like you have an indent after the for loop to kind of show that like, hey, this is the block of code I want to do. And make sure that you have the colon as well. For while loops, there also needs to be a colon too. Someone says, what is a while loop? A while loop is similar to a for loop, but it's indefinite. So you're doing the block of code over and over again. Rolls up for about 10 seconds. No. But yeah, a while loop. So you're basically doing it over and over again until the condition is false. So someone said I was doing spring flowers example, but while loop worked only once. After climbing one wall, it stopped. Then I had to use a for loop. Can you explain why this happened? I'm not quite sure like what happened without looking at your code. And I'm not like too familiar with the spring flowers question, but if you have like specific troubles with a problem you need help debugging or you need more clarity on a certain problem, feel free to post it in the forum. And if it's like a problem that's for homework, then post it privately and we'll take a look at that. Okay, so when I need to restart a problem, does it clear out the comments in the terminal from my previous attempts? So by comments in the terminal, do you mean like all of the error like comments, or I'm not sure what that means. But when you restart a problem, you can still scroll through and see all the errors. And that should like clear the terminal. Yeah, I thought the same. Why don't we have a function that simply says stop Carol? If we were to create stop function, is this a good idea? Stop Carol. I think Cameron's kind of answering that right now. He's typing, but oh, I think he's answered already. Let's see what Cameron said. Oh, I think Cameron said it can make things too easy. It's good for learning and thinking about your conditions carefully. Yeah, that's a good point. So like I think the reason why we want to like avoid using like a stop function or something is so that you're able to kind of think about your conditions and also like pre and post for while loops, things like that, to make sure that your code is running. I think that's also part of the reason why we prevent the usage of things like break and continue. Okay, see if there's any more questions. When I need to restart a problem, does it clear out the comments? Oh, I just answered that. Oops. Okay. I'm gonna skip any like questions about logistics. Feel free to ask them, and I think Cameron's going around and answering a bunch of the logistical questions as well. If you need help with like very specific logistical things about section or things like that, feel free to make a forum post privately or also email us. Okay. What is the difference between a for and while loop? Okay, yeah. So I think we kind of talked about how like for loops are definite, meaning that like you're doing the code a specific number of times and repeating that code a specific number of times. For example, I can say that I want to repeat this code 10 times, and that's called definite. Meanwhile, a while loop is kind of like, hey, I'm not sure how many times I need to do this. Maybe the world is 10 by 10 this time. Maybe the world is 15 by 10, or like, it's just a different size each time, since it's indefinite, and it will keep doing it until a condition is met. Okay. Oh, I didn't know you can clear out the questions. Oops. Okay. Someone asked, I wanted to know what a different variable name like J, K, and I represent and what I represents. Really good question, and I think we're almost out of time, but I have 3 minutes to answer this last question. But yeah, really good point, or really good question. I think the syntax comes from like a bunch of other programming languages as well, where you use I as like an index to go through a certain number of things. So what's kind of really happening is range gives you a list of like numbers. So like it'll be like 0 to 9 since 10 isn't inclusive. And what's happening in Python is I is basically representing 0, and every time it does one iteration of the loop, it increments. So I becomes 1, then becomes 2 and 3, and 1, 2, and 3 are obviously within the range of 0 to 9. So it'll keep doing that until it reaches 9. Um, and in the context of using J and K, those are also like indices for going through the loop, like one by one, like increasing from 0 to 1 to 2 to 3. But if you have nested loops, it's not good to use I over and over. So that's why people use J and K next. So J and K represent like indices for nested for loops. Hopefully that answered your question. Yeah. So what is my email if you have any questions? My email is how can you watch a session? It asks for password.